Hello and welcome to Pickles Garage. Today I'm going to show you how the future can help with problems of the past. Specifically, I'm talking about 3D printing and as it relates to the many plastic components that we find on all types of different vehicles. Now this part specifically, you'll know if you've ever taken apart the horn assembly on these square bodies, will go right here. And as you can see, very brittle and they break quite often. And so what you'll notice is you can find these online fairly easily, but paying for it, paying for shipping, waiting for it to show up isn't all that convenient. But maybe 3D printing can help. I do think 3D printing in a lot of ways is the future. I think manufacturers are going to continue to have problems supplying and getting the rights for and reproducing the many plastic components that are on more and more vehicles that come out each and every year. My 93 Z28 Camaro, for example, I have tons and tons of problems finding those cheap plastic brittle components that break on almost a daily basis, right? Usually I have to find them on eBay, and I do think that the 3D world will continue to improve our ability to kind of have freedom from buying old used parts, right? And so square bodies have a lot of support. This specific part, like I mentioned, you can find them fairly easily, but if we can create it ourselves, how great is that? Now, there are some pros and cons of 3D printing in general as it relates to this, and I'm going to go over that, but I also want to go over how you can take something from broken bits like this, design it, print it, test it, and be happy with it, as well as kind of the pros and cons of other things that you could do, as well as like fabricating completely new concepts. So let's dive into it. So let's start off by talking about the possibilities with 3D printing. To be honest, it's pretty much limitless. I designed this from scratch, and granted, it's definitely got some imperfections, mostly related to it being printed, but essentially I took a actual real piston and I was able to measure the different components of it, and I was able to replicate it at scale, right? And so you're able to do incredible different things, designing in a lot of different, fairly easy to use and often free software to build whatever your mind can think of. Like, the imagination is the limit, right? And so naturally, not everything like this would actually work in a vehicle, but just to give you the concepts of what you can potentially do with it is really up to you. And so naturally, you're going to want to have a fairly decent digital caliper to do some of these specific measurements, and just basic tape measure and things like that, depending on what you're building, is going to continue to help you. So there is with that a level of buy-in that you have to do. Naturally, you're going to want a somewhat decent laptop, so we'll start there. I guess technically we started with caliper, so you are going to want this, but we'll move on to the laptop. The laptop, I did a bunch of research to see if it really mattered what kind of laptop I had, and I continue to get a resounding no that it doesn't matter what kind of laptop you have. You can create on anything, but I will say if you are going to get something like a Chromebook, which isn't technically, I guess, a laptop for a lot of people, it's closer related to a tablet, I think, in a lot of people's mind than a laptop. But if you are going to get a Chromebook, then you are going to be limited by some of the software you can get. You can do it, and I'll show you how, because I did make the mistake of, I'll just do a really cheap buy-in, and I could do everything on any laptop, right? And so I bought a Chromebook, and really, I should have gotten a decent laptop. So looking back on it, get an actual decent laptop. So you're going to be already in the hole about 100, 200 bucks there, maybe more. The printer itself, 3D printers, you can get a fairly decent one. I have an Ender V3, I think. And I found it on Amazon. It is about $300. So you're already in the hole, 500 plus at this point. So I know what you're thinking, why wouldn't I just buy the $12 part? So in reality, this is all about future kind of investment, as well as what you are limited to with your specific vehicle. So if I only had square bodies, maybe it wouldn't be worth it if I didn't have that extra layer of like intrigue to design and build things myself. That's absolutely possible, right? But again, with my 93 and me being continually limited on what I can actually, purchase, it is continuously going to be a better investment. Now, I had many reasons for my own personal desire to get it. So again, it does just kind of depend on what your level of interest with it is. But again, buy-in laptop, digital caliper, the actual 3 filament. Typically, people are using like PLA. That's like $20 or less a roll. The rolls do last a long time, and you can print a lot of different stuff. Like I was printing all kinds of crap, and I still haven't rolled. I haven't ran out of a roll yet. Just the trial one that comes with my printer. But again, those are some costs that you have to take into consideration about what your buy-in is. But it's not so much about what one individual cost or repair will be. It's more about, again, the options that it continues to give you. And eventually there's definitely going to be savings, and there's definitely going to be opportunities for you to continue to benefit from having a 3D printer. Because again, I think it's the future in a lot of different ways. Now, looking into my specific situation of designing from the ground up, I do want to show you some of the programs that I found that made it possible for me to literally take something that no one else had built, no one else designed for me. I did it from the ground up, and I was able to do it within half a day or less. And so majority of the time that I spent on this was the time it took to print it. And so let me show you some of the things that I found extremely helpful when I was first starting out, and then you can grow from there. Okay, I know filming a screen, not really great, not ideal, but bear with me. So essentially what this is this is going to be your base for designing things. Now, if you are going to get like an actual full-on laptop, they have a lot of different like programs. I think that would be really helpful to help design different things. This is Tinkercad, Tinkercad. It's online, it's free, which is even better news. You just create an account and you're able to do really anything that you should need to do. Like I said, there's a lot of different like software that you could download that I think is extremely helpful, but as far as having a Chromebook or just doing entry level kind of fiddling, this is a fantastic program to really get started. And so very straightforward. You're able to add objects, you're able to change the size of things. You can click and drag like that, or you can click it and then make that 34 or whatever. You're able to change a lot of the just different dimensions. You're able to change degrees, or change degrees like that where it's actually in sections. You're able to move it around. You're able to click and raise it with that, and you'll get really comfortable with it over time. But you're able to add other objects in, and say you want to center that object, so you can click this, shift, click this, I can click that, and then I can center it. I can put it on top of it, whatever I need to do. So there's a lot of different options for you to interact with things. Like now I've made this all the same object, so naturally this isn't anything, this is just random nonsense, but the point is everything is limitless. And really what you have to do is, rather than thinking about things individually, you have to think about how objects interact with each other. So that sphere that I've just added, I can now make that into a hole, and then I can combine it to our random object here, and so now there's a hole in it, right? So again, this is a nonsense item, but it really just showcases what you can do and what you can create as it relates to car parts. So Tinkercad is fantastic. Like I said, it's free, which is great. So now it's hovering above, but I can drop it back down. The other thing too, and I know I'm going through this really fast, but essentially this isn't about showing you specifically how to use just this program, because that could be its own hour-long video. But this is more about showing your pros and cons. But basically, you can use this ruler to help center things. And so a lot of different options here. But if we were really happy with this object and we wanted to save it, basically all I have to do is you do export, and then you'll get an option to do an STL, right? And so this is I guess the most confusing part for me when I was starting out, is having a hard time getting this information. But once you've designed something and you're happy with it, export it, STL, save it, and then you're going to take that STL and you're going to have to go into a whole nother program, right? This whole separate program is Kirimoto, also free, also online. Also, there's tons of other programs if you get a genuine laptop. I'm blanking on the names because naturally I don't use them, but if you do some research and you'll find out which slicer they call them is best. There's really fantastic ones out there, but again, Kirimoto does the job fantastically. And basically you just import a file and you're going to grab that STL and you'll place it in here. What this does is, the first thing was you designing something in the 3D world, right? This is going to be telling your Ender 3 what it's creating, what it's designing, how it's going to orient it on the table, how it's going to print it. And so you need to have both sides of it. You need to have both the design of it, and you also need to have the way for it to communicate to your printer. So what you do is, when you start and you hit slice, these are the layers that it's going to take. So you see those are each of the layers that it's going to print. And so it's important to kind of know if there's going to be any issues with it printing. Like if you have an overhang that doesn't have support, then you can add it. And again, like there's so much you can go into as far as like bed temp, nozzle speed, all that I can't really go into just because this is more of a concept video. But if you really get into 3D printing, this is a whole nother avenue to kind of figure out the best ways to do this. But again, you would export it into a G code, and your G code is what you'll actually take to your printer, and your printer will print it. So at a high level, this is what you would be able to do from start to finish on a project that you make. Now, the reason I wanted to show this too is because I keep talking about how 3D printing is the future. We have a specific problem. We want to create that sort of plastic horn element. Well, there's another website, and this is called Thingiverse. And essentially this is an open forum for people to create things. And they're able to come up with different concepts and designs that they put together. And you are able to download it for free, the G code, and you're able to put it into, or usually it's an STL. So you're able to download the STL for free, and you're able to take that, put it into your Kirimoto, upload it, and then you're able to create that G code and then print it out. And so I wanted to go ahead and run through actually designing this, but I was excited to see that this actually exists in Thingiverse. And so again, the more people get into this and we start kind of designing these different concepts, and people are able to print them for free, essentially, once you actually have your printer and your filament, then it's just a great community that we're able to continue to utilize these plastic things that are going to be breaking, and it's going to be a much lower individual cost for each of these items. So I'm going to be able to print this out in my PETG, which is a different filament that's a little harder, and I'll be able to put this to use. But I wanted to show you also the concept, because this is basically, it's not the exact replication of the design, because that would be a licensed product, I'm sure. But this is a version of something that I'm going to be able to use as a retaining ring for my use. Now, I'm also going to show you myself designing something that isn't a replication of something that exists already. This will be me designing something to 3D print that's supposed to kind of help fix. So let's dive into that. Okay, so now that we've seen something fairly basic when it comes to 3D printing on a car, I want to show you something a little bit more complex. So, in this case, if you have any square bodies, you're probably pretty used to seeing this situation where the horn element, these tabs will break off. And so you constantly see it where a tab is missing or you have to remove it and it breaks, and you can find new ones of these, but they're like 50 plus bucks, and then you don't get the kind of that classic look of the original, right? You get something probably made in China that's a little bit of a cheaper quality. And so maybe you want to keep your horn element, which is the boat that I'm in. And so as I was addressing this issue, I wanted to come up with different designs and play around with different sort of concepts and materials that I thought would help. And so naturally, like I mentioned on the previous one, you can buy those parts, and maybe they're relatively cheap, and so maybe it is easier just to buy the part. But to potentially save $50 and keep the original look, it is kind of worth it just to play around with different designs. So there's a couple different iterations on this. I started off with this one, which albeit is pretty complex. Essentially, I was hoping that I would have the tabs here similar to this, and then it would go into the inside, and then it would sort of lock with these nubs and the holes that are around here. So I think it would work perfectly. Honestly, I think it was a fairly decent concept, but it was too big initially. And the other issue was the tabs. As you can see, one is missing here. Were pretty brittle, and so it broke off almost immediately. And so this one is barely hanging on by a thread. And so the main issue that I was having is there was just no flex. And so you'll see this one's broken too. I was kind of playing around with this. And so my original idea of, let me just shrink this down and then it'll snap into place and it'll be great was kind of going out the window, right? Because if these tabs are going to be super fragile, then if I try and put it back on the steering wheel, it's just going to break and it's not going to work, right? And so my next design was similarly just kind of adding some supports. Same thing tab here wise, but I played around with the dimensions, played around with the sizes. I did two different designs for this, just to see if I can come up with something that was a little bit more strong, but also had a little bit of give. But as you can see, I'm pushing pretty hard on this, and it's not moving an inch, right? It's not moving a millimeter, which is really all I need. And so in the end, I realized, okay, so maybe it's the material. Maybe no matter how I design it, this just isn't going to give me a lot of give. So 3D printing, what you're going to realize is there's a lot of different material that you can print with. A lot of people are using PLA, which is what this is. It's really great for sort of like internal, or sorry, not internal, just inside structures that aren't really going to do anything or just going to kind of hang out inside. And you can get a lot of different colors. You can do a lot of cool things with it, but as far as applications in the automotive world, you're not going to have any give. It's a little fragile. A lot of heat. It's not really going to stand up well to it. So, as much as I wanted just the concept to work before I really started playing around with materials, I realized that I wasn't really going to get very far until I changed materials. And so that led me to this point. So, what this is this is PETG filament. It's supposed to be a little stronger. It's supposed to be a little bit more flexible than the PLA. And so I wanted to test the tabs concept before I made a whole new structure, which essentially was going to be the exact same thing that is, right? And so I played around with it, but what I found is the ones that were thin and more realistic broke off pretty easily, and the ones that had sort of that more support weren't really flexing. And then I even got my hopes up on this one when I was pushing it and it was giving the slightest amount of give, which you can almost see there. But then the more I looked at it, the more I realized it's actually the bottom plate that's moving. And so this isn't moving at all. And so in the end, I realized no matter, even on a more flexible material, it wasn't going to work my original design. So I decided let's get a little bit more simple. And so that is what led me to this. So basically, what I realized is all I really need to do is rely on these other tabs to keep doing their job. And so as long as I have some wall here that is keeping everything in line on this side, then the actual give still just needs to be in these remaining tabs. And so I oversimplified the idea, and I think it's going to turn out better. So on this first one, diameter was, I think, way too small. So basically this went in, right, and it's kind of sliding all around. But for the most part, I think it's lined up pretty well, and it showed that the concept was pretty decent. And so this actually kind of does a little bit of the overhang, which I was hoping for, but realistically I need to get all the way to this band. So I realized that the overhang wasn't enough. And so that led me to the next one, right? Same thing, sliding in without breaking any more of my tabs. And so now the diameter was good because it's a nice snug fit, and the overhang is perfect, right? Because it lines up right as it should, but now it's a little too tall. It doesn't rest all the way down. And so my latest one, which is actually printing right now, is a couple of millimeters shorter. And so it should fit nice and snug down in, and I'll be able to go ahead and test out this design. But like I said, this is the sort of thing that you could start doing with 3D printing related to automotive stuff. You know, naturally you can replace this, but again, if you're wanting to look for your original look, you don't want to try and glue it different tabs or anything. Like, you don't want to try and re-glue that, and maybe it wouldn't work anyways because it still has to have that sort of flex. So if you don't want to do anything like that, then you can kind of open the option to design some different stuff, and maybe you'll think of something way better than I did. But like I said, that's just kind of one of those opportunities that you can do in the 3D world for printing, you know, with automotive stuff. So like I said earlier, on that cheaper piece, I know it doesn't make sense for a one-off for you to be like, okay, you know, I don't want to buy this $12 piece, so I'm going to buy a $300 printer, and et cetera, but when you start to look at the different options that this opens up, as well as focusing on cars that maybe parts aren't as readily available, especially like 90s vehicles with a lot of that being plastic, this does sort of open up some options that you wouldn't have. So it's not really about saving money anymore, it's more about actually being able to create something that you wouldn't have the ability to have otherwise. And so real quick, I'm going to show you just some different designs that I did with this, and kind of as I was scaling up and tweaking different things, I'm going to show you the designs I did on that, and then hopefully by then my fit will be done and everything will work, and I'll go ahead and test it out for you guys. So once again, we have our Tinkercad, where you do have tons of different options. Really, it's about thinking about everything in a series of objects. And so, you know, yeah, your options are basically like square, triangle, whatever, but what does an object look like that has a square with a triangle through it? You know, what are you able to create as, you know, you start piecing things together? And so that's how you're kind of able to come up with some of these elaborate things. Like, you'll notice the top is a lot thicker than the bottom, and that's because I had a cone going through it, and then I deleted out the cone. And so that gave me less print time, but it also gave me more of a base for me to create this sort of arch here and have that strength element to it, which ultimately was too strong. But like I said, you know, if you're going to be designing something that's never been done before, 3 or so different iterations really isn't too bad. You might continue to improve it after you test it. You know, it's not just about fit, it's about, does it actually do the job it's supposed to? So it's definitely an ongoing adventure. But I think it's unique, and I think it is kind of helpful to give yourself the options for it. You could test different things. Like you see, I had the arch here, and then that tab that was missing on the other one, I just gave it a stronger base, which ultimately didn't really help at all either. So different things that you could test. And again, Tinkercad, it's free, it's easy to use. It's fairly intuitive, you know, you can watch videos on it, but more or less if you just kind of play around with it, you'll start to get the hang of things. And so the other thing, naturally, once you do your Kirimoto, that is your ability to slice it. So this is the one that's printing now. You'll see that it gave me, or I gave it some of the enhancements I talked about. It's a little shorter, but I also put really small holes at those ends. Basically, I'm thinking of a way to kind of lock it in, and we're going to test that out as well. But let's go check on the print real quick. So it's still pretty early stages, but you can see the holes that I had pointed out, and it's printing each of those layers, which is great. And so hopefully this turns out the way we're hoping. So next shot will be the fitment, and then hopefully I can go ahead and test it out on the wheel itself. So here we go, right before our eyes it all came together. So you'll see that it no longer bottoms out. The lip is nice and flush to the edge, and so it'll effectively hold right where these other tabs are holding without the same issues. And so this should work just fine. It's got the holes like I mentioned, one on either side, so if I want to get really creative to lock it in, I can, but honestly just holding it, you know, I'm holding it from just it and it's not going anywhere, so I don't foresee any issues there. So this looks good to go. So like I said, I mean, there's a lot of different things to play with. I'm sure there's better designs, and I'm sure there's, you know, going to be some adaptations that I take with it over time, but really this is just an example of something that's completely undone before, you know, as far as I know, and designing, creating, printing, and being able to do it in a relatively short amount of time to hopefully be able to utilize my horn and not have to buy another one. But like I said, you know, if the community comes together and we're able to print different parts, it's just going to be helpful to all of us. And you know, if you get creative solves like this, I'm sure they'll be welcomed by plenty of other people. So definitely something to, I think, start getting into. I think if you're into cars, you're into building, you're into designing, then the 3D printing world brings it all together. So thank you very much for watching, and I'll see you on the next one.